Okay, chapter 1, I'm going to go through a little bit again through the chapter 1. Important thing is you need to understand the chemistry, how we use chemistry to study matter. We're going to talk about chemical changes. And we also going to talk about scientific method. And we also going to look into how measurements are reported in science and how we make measurements and how we convert units in measurements. And we also going to look into factor label method, where the units are used to do the calculations. Then we're going to look at the state of matter and properties of matter, such as density and specific gravity. And we're going to talk about energy. Matter and energy are different. Energy is manifestation of matter. When an object moves, you can see energy changes. Therefore, you see the movement. Gone over during the last class period about chemistry. Chemistry mainly deal with chemical changes, where substance is changed. When a change take place, if the substance change, that's called a chemical change. If the substance didn't change, it's going to be called physical change. We go through examples, burning liquid petroleum, melting ice is physical change. I have put these questions. You can go back and look at it. Okay, how you find out physical changes, chemical changes. Now we going to briefly describe the scientific method. Scientific method start with the observation from the bottom and look for patterns in the observation. And then we come up with the trial, theory, or hypothesis. And hypothesis became a theory. And theory could be tested with further experiments. And do you guys have a question? Okay, there are few steps in the scientific method. You need to understand those steps. Observations or measurements are also called facts. So they are the ones we deal in sciences. Hypothesis is a proposed explanation that would become a theory later on. Then the theory also could change depending on new observation. So go through these. We already gone through some of the examples for scientific method. The measurements or observation are important to scientific method. We're going to look into certain aspect of science measurement. Measurement could be quantitative or qualitative. Quantitative is when you have a number and the unit. Qualitative is when you describe using words, verbal description of observation, like this car moves faster than the other car. There's no number involved. So measurements use quantitative measurement use units such as meters for length, liters for volume, grams for mass. Unit have systems. Metric system is the one you going to use. So we're going to look into how to convert units. We looked at it. The number part of the measurement could be expressed in scientific notation. You should be able to convert normal form to scientific notation or scientific notation to normal form. For example, 2.800, 10 to the 2 is the scientific notation. So you move the decimal place to the right and get rid of the exponent. It's 280 in normal form. You're moving decimal place. So do the problems. Metric system have base units. Length base unit is meters in metric system. Volume is liters. Mass is grams. Time is seconds. Temperature is Kelvin. In chemistry, we also use mole. Mole is the amount of substance. We're going to look into that. These are the basic units that we use in science. Just do these problems to convert scientific notation to normal form. Or figure out what is the largest number. In problem 48, largest number is B.
B.
Yes. We go over some of these. What is the answer to 50?
It should be C. C.
Yes.
I think it's
Yeah. We go over these. Measurement 5,342 nanometers in centimeters. Nanometer is 10 to the -9 meters.
A.
A is the correct answer. Oh, it's D. How do you get D?
Don't you convert from nanometers to centimeters?
Let me write down here. That's the number. You convert it to conversion factor is 1 meter is 10 to the negative 10 to the 9. The bottom is nanometers. This is nanometers. Negative 9. 1 nanometer is 10 to the negative 9 meters. Then centimeter is 1 meter, 10 to the 2. That becomes 10 to the 7. 5.347 multiplied by. So when you convert this to, it becomes that 3 decimal places. 7 that negative 7. So if you move on the 3 decimal place to left, 7 becomes 6, 5, 4. That's the correct answer. Can you understand what I did? What I did?
Yes. Yes, sir.
Okay. This is the metric prefixes that we use to express units. That's where I got the conversion factors. For example, 1 meter is 10 to the 9 nanometers, or centimeters, we use this one. So you can get the conversion factor to convert. That's factor label method. We go now some of that. Significant digits or figures in a number like this, in a measurement like this, significant figure is used to show how accurate is the measurement. This one has 4 significant digits. Number as written, this is the uncertain digit in the measurement. That's where we round off. You count from the uncertain digit to the left, 1, 2, 3, 4. That's how you get significant digits. This one has 2 significant digits. So go through these problems and find out whether you can get the significant digits. There are certain things about zeros. Trailing zeros have a decimal place is significant. Leading zeros in the whole number, leading zeros is zeros before the number, are not significant. There are numbers called exact numbers. Normally in the conversion factors, for example, 1 inch is equal to 2.54 centimeters. There's 1 and 2.54 here. Those numbers don't have significant digits. When you are doing calculations, you assume they are not contributing the uncertainty. I'm going to show a little bit later how the exact numbers doesn't affect calculation. For example, definition, there are 10 fingers, 10 toes. 1 meter is 100 centimeters. They have no uncertainty. Therefore, they don't have any significant figure. For example, this has 3 significant digits. This has 5. This has 2. How many significant digits are there? Figures.
3.
Correct. This one,
6.
correct. These are not significant. These
One has
is
3 or one has 1.
the leading zeros are not significant.
Mhm.
Zeros are to the right side of whole number is not significant. Therefore, this one is 3. This one is 5. When you use measurements and do a calculation and use the measurements, adding 2 measurements, 100 kilograms, this has to be same, 100 kilograms, subtracted 3 kilograms, 3.6. Answer you get, calculated answer is, this is the calculated answer, is 6.51. But we had to round this off to first decimal place because the lowest decimal place in these 2 numbers, that's the second decimal place, that's the first decimal place. This has more uncertainty. Therefore, number has to be rounded off to 5. There are rules for rounding off. If you need to round off here, you look at the next number to the right. If it is between 0 and 4, you just drop it. If it is greater than 5, between 5 and 9, then you add a 1 to 5. So that's about getting the answer with correct significant figures. Do you have any question about adding or subtraction? You look at the lowest decimal place and round off the answer to that lowest decimal place. So we have problems here. For example, that one. That's the calculator answer. Which decimal place we need to round this off to? Second decimal place. Why? If you look
Is
at
it supposed
the
to have three significant figures?
one has lowest, you're not looking at significant figures. You are looking at decimal place. Addition, subtraction, you are looking at decimal place. This is decimal place is 2, decimal place is 3, decimal place is 2 here. Therefore, this has to be, answer should have been rounded to second decimal place. Therefore, answer is what?
Okay, so I have a question. So it depends on the which one has more decimal places in the equation. Is that what the answer is going to depend
Lowest
on?
decimal place.
Lowest?
Yeah.
Okay. Okay, thank you.
So it has to be rounded off. Now, I'm not going to talk about answer is C. That's how we got C. Do you understand it now?
Yes, sir.
Okay, there are more problems. This has to be rounded off to 8 here. Why?
Because it just
Lowest
says
decimal.
the lowest have two decimal places.
Yeah, 2 decimal places. This is the one with the lowest. Therefore, answer is, this is 4. Therefore, we just drop it. Answer is this.
Mhm.
Okay, we are not going to do everything. You can go back in the slides and do the problems. When you have multiplication and division, when you do a calculation and trying to get the correct rounded off answer, you don't look at decimal places. For example, if you divide, this is a division. Multiplication and division follow the same rule. You're not looking at decimal places. You are looking at significant figures, multiplication and division. How many significant figures are in here?
4.
4. Bottom one,
2.
when you do the calculation, you get, this is a calculated answer. What is the rule for multiplication and division? The answer should have the lowest significant figure. Lowest significant figure is 2. To have 2 significant figures, 1, 2. This has to be rounded off to first place. First place. Since this is 8, you had a answer should have been 64. Do you understand that now?
Yes.
Yes, sir.
That's the place you had to round off. I wrote down again. When you have 8, eight is the first digit to be dropped. 63 is to be retained. So you get 64 miles per hour. Okay, addition, subtraction follows decimal places. Multiplication and division follows significant digits. Rounding off in both cases are similar. If the number to be dropped is between 0 and 4, you drop the numbers, remaining numbers. If it's between 5 and 9, you add a 1 to the next number. This is about multiplication. The number should have two significant digits. So 1 with the significant digit 2 is this. Do you see that? Multiplication follows the significant figures. Therefore, answer is 39. So go through these problems. Now, conversion factors are important. Conversion factors I talked about, 1 inch is 2.54 centimeters. You use conversion factor to do calculation. That's called the factor label method. You start with remember we start with nanometers and convert it to centimeters. So you use the conversion factor to follow the calculation. For example, if you have this conversion factor, 1 kilogram is 2.21 pounds. You could write it down in two forms. A conversion factor also could be written in two forms. That as a factor. So which one you use depending on the original quantity. If you're doing pounds, the pounds have to be cancelled out. Therefore, you use the conversion factor, this one here. So you can pick up the conversion factor depending on the original quantity, units of the original quantity. That's called the factor label method. Factor label method is using conversion factor to convert quantity in one unit to quantity in another unit. Units are treated like numbers. How do you convert 1 or 3? You use the pounds at the bottom. For this one, same thing. Which conversion factor? We use pounds to kilogram. That one where the pounds is cancelled out. And kilograms will be use this conversion factor. Pounds will be cancelling out. Answer is 59. 59 is for the correct answer. This one has two significant digits. These numbers are exact numbers we talked about there. Therefore, they are not considered in the calculation. Conversion factors, numbers coming from conversion factors are not considered in the calculation. So that's how you use conversion factors. There's a difference between mass and weight. What is the difference? Mass is compared to a standard weight. Therefore, standard weight is mass is independent of location. If you calculate the mass with the balance with the standard weight, it's same whether in Earth or Moon, mass is same. But the weight is depending on the gravity. It's like a spring balance, where your spring is used to weigh based on gravity. Therefore, it depends on the location. Therefore, you have to know mass is the one we use in sciences. Sometimes weight is, if you hang around only on Earth, weight is same as mass. We talked about metric prefixes. Giga is 10 to the 9. Mega is 10 to the 6. Kilo is 10 to the 3. These are the conversion factors. 1 meter is 10 to the negative 9. You have to, if you look at this, 1 meter is how many gigameters? Because this is the larger quantity. 1 meter is smaller than that. Therefore, when you are getting the conversion factors, you follow sensible statement. So that's how we got the conversion factors for converting one metric prefix to another. Some of them have Greek letters. Only Greek letter we have is for micro, 10 to the negative 6 micro. All are big letters or small letters. So only Greek letter is micro. Increasing corrected order length, that's greater. Therefore, large one has to be on the left side. So this seems to be the correct answer. Okay, you go through this. I'm going to show you how I got this. One, you start with what is in 1 mega. Megameter, 10 to the 6. 1 megameter as 10 to the 6 meters. Therefore, centimeter is 1 meter as, so this becomes 9. Do you see how I use conversion factor to do calculation? Do you have any questions?
No, sir. No.
Okay. As I said before, you use the conversion factor with correct orientation to convert the original quantity to a desired quantity. These are the metric and English system conversion factors. This will be given to you. Then you use the, for volumes, 1 quarter is 4 cups. So you can do conversions using factorable method. How do you convert 381 grams to pounds? You write down 381. And the bottom, then this one has to be canceled out. Therefore, you write this one is where the grams is at the bottom. Therefore, pounds remain. That's how you do factor label method. Gallons to milliliters. This is the conversion factor, gallons to liters. Milliliter conversion factor is liters. 1 liter is 1000 milliliters. So liters cancel out, you get the answer. Okay, I'm not going to talk about all these. If you look at this, I have lined up different. For example, if you start with 200 yards, then what is in meters? Metric length is meters. You cannot yards to foot, feet, and feet to inches here, and here inches to centimeters, centimeters to meters, then you do the calculation. You get 138, 183 meters with 3 significant digits. Look into this carefully, then find out how you use the factor label method to do the conversion. I'm sorry about that. We're going to do the temperature. Do you guys have any questions?
No, sir.
No,
Alright.
sir.
The temperature is expressed in 3 units, 3 types of units: Fahrenheit, Celsius, Kelvin. So you need to be converting one to the another. Fahrenheit is, Celsius is converted to Fahrenheit. By converting the scale. Scale in the Fahrenheit is 180. Celsius is 100. I'm going to, therefore, to convert Celsius to Fahrenheit, use this 1.8 coming out of scale proportion. Then you add a 32. Once you remember this equation, to convert Fahrenheit, you rearrange this equation. The C is here on this side. Then minus 32, you get that. To Celsius, to Kelvin, you add a 273. From Kelvin to Celsius, it is subtraction. So this is the scale factor, Fahrenheit. 0 to freezing point to boiling point. So that's what the scale factor is. Scale factor is 1.8, 180 divided by 100. So that's how you do. So I have done the calculations for what is the Kelvin Fahrenheit to Kelvin. To do Fahrenheit to Kelvin, you have to convert Fahrenheit to Celsius. That one. So you put that equation, first equation we had, then calculate the value. The value is 37. Normally body temperature is 37 Celsius. Then convert Celsius to Kelvin. You add a, this is addition 310. Please make sure that you done these problems. I am going to talk about little bit more about matter. The matter is made out of atoms and molecules. If you break up all matter, there are substances and mixtures. One thing about substances, they have fixed chemical, physical properties. Mixtures have variable physical properties. For example, gold has fixed physical properties, melting point, boiling point. Gold is an element. Element is something that made out of one kind of atom. Compound is two kinds of atom. There are covalent compounds, ionic compounds. Compounds made out of ions are called ionic compounds. Sodium chloride in this picture. Water is a covalent compound or molecular compound which has covalent bonds between hydrogen and oxygen. They have fixed physical properties. On the other hand, mixtures have variable composition, therefore variable physical properties. This one is an alloy. Alloy is a mixture of metals. like brass, copper, and zinc, is called homogeneous. Homogeneous is uniform distribution of matter. Heterogeneous is heterogeneous distribution. The composition of the sample, there's water in the pan here. These are the iron gold nuggets. Gold nuggets are separated from water. Therefore, composition is not same. That's called homogeneous, heterogeneous mixture. Pure substances are elements and compounds. We're going to look into elements first. One single atom is called only one single component. For example, oxygen is two atoms. Therefore, oxygen molecule is a pure substance. They all have same composition because only one kind of atom is there. It cannot be broken down into more elements. It's the last small particle of atom. They cannot be broken down by chemical change. Aluminum, metal, is an element. It's made out of many aluminum atoms. Compounds. This is a chemical compound. This is the ionic compound. Sodium and chloride. Sodium loses electrons, donate it to chlorine, become chloride ions. So therefore, exist as sodium chloride exists as an ionic compound. It's a compound. It has 6 chemical and physical properties. For water, which is a compound, molecular compound, it's different from ionic compound. There's no ions. We're going to look into that later. What is a state of matter? What is a state? There are 3.
Liquid gas.
Yeah, say that again. What are the states of matter?
Solid, liquid gas.
Solid liquid gas.
Gas, liquid, solid. All right. This is the basic 3 states. For example, this one is a solid water, whole ice, has a definite shape and volume. Definite shape. Particles are close together in ice. That's a liquid water. Definite volume, no definite shape. They are still close together, but they can roll over. That's a gaseous water called steam. That's the third state. This has no definite shape or volume. So these 3 states have different properties based on what we talk about. The gas particles in a gaseous state moves all around. Now, when you change state from water to liquid or liquid to gas, that's a physical change. solid to water is called melting. Boiling is liquid to a gas. So there are physical changes. Physical properties depend on physical changes. One of the physical properties of a substance is boiling point, where the liquid goes to a gas, boiling. Melting point is that. Solubility is dependent on the type of compound. For example, oil doesn't get into water. It's not soluble in water. That's a physical property. Color is also physical property. Sulfur is yellow color. Odor, how it smells, also depend on the properties of the substance. There are different states of matter. On the chemical properties, on the other hand, during a chemical change, substance is converted to another substance. So chemical change is different from physical change. For example, these are hydrogen and oxygen. When you burn hydrogen in oxygen, you get water. If you look at here, that in the products side, which is the after the reaction, you look at the substance. Substance is water. Therefore, substance change from oxygen plus hydrogen to, that's a chemical change. So chemical properties could be corrosiveness, flammability, how fast it goes into flame, etc. Corrosiveness, flammability, etc. Now, last thing we're going to talk about is physical properties. Density is one of the physical properties. Density is ratio of mass to volume of a substance. Mass divided by volume. When you need to calculate density, if you know the mass and the volume, you divide. Use the equation. Mass is known, volume is known, you get the density. This is the density, mass in grams, volume in milliliters or cubic centimeters. You use the factor label method also. If you knew the milliliters of a sample, how do you convert it to gram? You use the density as a unit conversion, factor. Density is a conversion factor between volume and mass, or mass to volume. So it's very useful identifying certain amount of material. Specific gravity is related to density, but specific gravity is density of a substance divided by the density of water. Therefore, units cancel out. Density, specific gravity is dimension, have no units, dimensionless. Therefore, either we can use density or specific gravity. How do you calculate the specific gravity? Density of the material divided by density of water. Density of water is at room temperature, 1.00 grams per milliliter. So do the calculations where density is calculated or use the density. That's the density of mercury. These are the unit conversions. One quart of mercury, that's the 1 quart of mercury converted to pounds. We use the conversion factors and the density is among one of them. That's the density as a conversion factor to grams to cubic centimeters. So you need to go through these calculations. I'm going to go through forms of energy and talk about heat as a form of energy in chemical reaction. Energy is a part of the world, part of the universe. Matter is there and energy is there. You can see matter through energy changes. Therefore, energy could be showing up as moving objects. Moving objects have kinetic energy. Or objects at certain position has a energy, potential energy. There's an interplay between kinetic energy and potential energy. In a pendulum, kinetic energy is converted to potential energy and then back and forth. These are large objects show kinetic energy and potential energy. Small particles also show potential and kinetic energy. The thermal energy is large, small particles. Thermal energy is how fast atoms move in the sample in small particles. Kinetic energy could be expressed, shown as mechanical energy or electrical energy. These are at small scale. Electrical energy is moving electrons. create electrical energy. Moving electron also create magnetic energy. Therefore, it's related to kinetic energy. On the other hand, potential energy is chemical energy, where the bonds, when atoms are placed in a bond, therefore placement creates certain amount of energy. Therefore, when you break the bonds, chemical energy is released. Material have elastic energy. When you stretch, that's a potential energy. Nucleus also has bonding, nuclear energy, when you break up nuclear particles. Gravitational energy is potential energy based on placement of an object in an orbit or high up in a mountain, have more potential energy. So we need to know how these relate to each other. Energy is defined as capacity to do work. Energy is shown by moving object or known as kinetic energy. If an object made out of matter moves, it has kinetic energy. Another form of energy which are common to matter is potential energy. Potential energy is energy an object made out of matter has because of its position. A rock on the bottom of a hill has lower potential energy than the rock on the top of the hill. Rock can fall down and release energy. That energy is potential energy. Moving object has energy. It's called kinetic energy. Kinetic energy is calculated by multiplying its mass times velocity squared, 1/2 of 1/2 mass velocity squared. So as the velocity increases, kinetic energy increases. As the mass increase, also the kinetic energy increase. Now these are the two forms of energy which is common that's seen in the matter. Objects are made out of matter. We talked about matter. Matter is something that has mass and take up space. Example of kinetic energy is mechanical energy. Mechanical energy is when a car moves along the road. That is a mechanical energy. You can move certain weight, certain mass in the car, certain weight, certain people in the car. From the mechanical energy created by the machine, internal combustion engine in the car. So heat is also a kinetic energy. Heat is due to kinetic energy of particles making out of matter. Particles move faster, more heat it has, or temperature is higher. Heat temperature is an indicator for amount of heat. Higher the temperature, heat is most. Lower the temperature, lowest heat. Also, electrical energy is also a form of kinetic energy. Electrical energy is fast moving electrons through a conductor. When you apply the potential, electric potential, the electrons flow from negative end to positive end. A current is passing through positive end to negative end. You probably heard about that. Therefore, energy, mechanical energy, light energy, heat energy, and electric energy are kinetic energy. Kinetic energy. Can someone turn off his mic or her mic? I hear some noise in the background. If you need to ask a question, you can turn on and ask, okay? In chemistry, most of the important forms of energy is potential energy. Also, atoms have chemical energy or nuclear energy. Chemical energy is energy in the chemical bonds. It's like a potential energy due to the placement of atoms in a bond. It has certain energy. Bonds need to be broken by providing energy. Potential energy is a form of potential energy. Nuclear energy is produced in nuclear reactions where nuclei break up, losing mass of nuclei. Enormous amount of potential energy is released during a nuclear reaction. Chemical energy stored in substances are used in energy production for our day-to-day things by burning carbohydrates, fats as we eat our food. Stored chemical energy is the main source of energy that we use to do our daily routines. Chemical energy is a potential energy that is given off in a chemical reaction. If you burn carbon with oxygen, it produces carbon dioxide and energy. One of the important thing about energy is it follows law of conservation of energy. Energy neither be created nor destroyed is the law of conservation of energy. That means energy is already here. Only we can convert one energy from one form to another. All right. So this law of conservation of energy is called first law of thermodynamics. What is first law of thermodynamics? It is the law of conservation of energy. Energy is neither created nor destroyed. One form of energy that is important for us is heat. Heat is related to temperature. Heat is transferred from hot object to a cold object. Therefore, Temperature is the one that decides which way the heat energy is transferred from an object. Heat energy is in the atoms and molecules and ions making up the matter, piece of object, which is made out of matter. 0 calories. Calorie is not a part of SI units. SI unit is where kilograms, liters, Kelvin, those we talked about. That's unit 6 base units. Heat is expressed in joules, not in calories. But we normally measure heat in calories in normal work. But in scientific work, heat is measured by joule. 1 calorie is 4.184 joules, or 1/4 of a calorie is equal to 1 joule. Heat absorbed by 1 gram of any material to increase temperature by 1 degree Celsius is called the specific heat of that substance. In the previous slide, we defined calorie as a specific heat of water. In the table, specific heat of water is 1. Units of specific heat is calories per gram per centigrade Celsius. So that means heat required by 1 gram of material to increase the temperature by 1 degree Celsius. If you look at the specific heat of various different substances, they are quite different. Water has the highest specific heat. You would imagine copper, lead, metals might have larger specific heat. They don't. Water is the one that absorbs most heat per gram to increase the temperature by 1 degree Celsius. So the specific heat is a physical property of a substance or pure substance, elements or compounds. So we can identify, if we know the specific heat of a substance, what that substance would be. We can find out. So we do also calculate heat absorbed by certain material, substance, using specific heat, which I'm going to show in the next slide here. The following equation gives the relationship between specific heat and amount of heat and the mass of an object, and also using temperature change. SH means specific heat. Small m means mass. Big T2 minus big T1. Big T is the temperature. T1 is the initial temperature. T2 is the final temperature. If you have a problem like shown below, an example, you are asked to calculate how many calories are required to heat 350 grams of water from 23 to 95, and the specific heat of water is given 1.00 calorie per gram per Celsius degree. Now, if you look at this, in equation is HS specific heat times mass T2 minus T2, T1. So T2 is final temperature. T1 is initial temperature. So specific heat is written down to calculate the amount of heat times 352 grams. Problems in the problem, mass of water is 352. Then I substitute T1 23 and T2 95 because water increased the temperature of the water from 23 to 95. So when I do that, I get 2.5 10 to the fourth, or calories converted to kilocalories divided by 1,000. So I get 25 kilocalories. So we can convert this to joules using the conversion factor. 1 calorie is equal to 4.184 joules. In this case, we leave it at calories, kilocalories. Chapter 1, that's a compound is substance made out of two different kind of elements. Water is also a compound of hydrogen and oxygen. Now we're going to look into some problems about this type of classification matter. Elements and compounds are both classified as pure substances. Is it a true or false statement? Elements and compounds both are pure substances. That's true. About the compound, when a strong magnet is brought near a sample that contains both iron and sulfur, that sample has iron and sulfur in it. We don't know what form. The iron and sulfur are not separated from one another. So it should be a compound. If a magnet is brought into the sample, iron will get attracted to the magnetic field and could be separated. So this is an example of pure compound, a compound. So answer is not heterogeneous mixture or homogeneous mixture. So when you cannot separate from each other elements in a compound, that is a pure substance called compound. In this problem, sodium is highly reactive metal and chlorine is a non-toxic gas. When they are mixed, they form sodium chloride, which is essential for life. Which of the following statement is true when sodium and chlorine brought into contact with each other? So they normally react with each other. A compound is formed. If they are unreactive, then you have a mixture. Could be homogeneous or heterogeneous. So in this case, sodium and chlorine form compound, not a heterogeneous mixture. They form homogeneous mixture. Homogeneous is uniform distribution of atoms in the sample. They form a compound. Sodium and chlorine typically are reactive, so they form a compound. They may form heterogeneous or homogeneous mixture. Okay, the answer to the question 27 is C. nitrogen would probably be classified as a compound. Would that be a element or compound? This statement says nitrogen is a compound. Compound have two different types of elements. Nitrogen has only one element. Therefore, it's a false statement. Compound cannot be broken into simpler substances. That's not true. Compound has two elements. It can be chemically separated into two simpler elements. So therefore, it's false statement. Mixtures are the combination of elements, two different elements, element and a molecule, element and a compound, or two different compounds. The component of the element of mixture can be present in any mass ratio. The components of a mixture depend on the person mixing it up. There's no fixed ratio. The ratio between two components could be anything. That's true statement. Chemical techniques are required to separate the components of a mixture. Normally, mixtures are separated by physical techniques, distillation, filtration, like that. So this is a false statement. Mixtures are not separated by chemical techniques. Chemical techniques are required to break down a compound into elements. That's a compound, it's not a mixture. Therefore, mixtures does not require chemical technique. The components of the elements of a mixture can be present in any mass ratio. That's a true statement. But the second part of the statement, chemical techniques are required to separate the components of a mixture, is wrong. Therefore, two statements, one of them are wrong, and statement combining them, that's false statement. So still the choice A is the correct answer. The choice D, components, elements of a mixture cannot be present in any mass ratio and chemical. So both are false statements. Therefore, totally D statement is false. So only true statement is A. When a sample of a particular solid is examined under microscope, clearly distinguishable, black and yellow regions are observed. So when you have, this is the example we talked about, iron and sulfur. That's a heterogeneous mixture. Clearly visible areas. That means sample atoms or components are not distributed homogeneously. Therefore, answer. The change from liquid to solid is called melting. Solid to a liquid is melting. Liquid to solid is melting. Change from liquid to solid is freezing. Reverse is melting. Therefore, freezing is the correct answer. The freezing point of a water is same as its melting point. These are reverse processes. They are the same. Freezing point is same as melting point. So answer is A. What is evaporation? Evaporation is liquid going to a gas. Sublimation is gas going to a solid. Evaporation is liquid turning into a gas. D is the correct answer. Now, the matter has physical properties such as boiling point, melting point, solubility, how much. A substance has freezing point of minus 20 degrees Celsius. Choose the appropriate classification from the list of responses. It's a property. Property has a value, numerical value. Solubility, 20 grams dissolved, that's a property. Change is a description of change. It melts, ice melts, is a physical change. So therefore, that freezing point of 20 degrees is a physical property. Melted, substance is melted. Choose the apparent. This is a change of substance. There's no number to it. So that should be a physical change. C is the correct answer. The substance has higher density. Those appropriate classification. Density has a number associated with it. Higher density has a higher density value than the lower density sample. Therefore, it's a physical property. Now, on the other hand, chemical properties are also characteristic of substance. Explosion is a chemical change. Classification. Explosiveness is chemical property. Substance react with chlorine gas. React with chlorine gas is the chemical change. Substance undergo chemical change. It is always true that it freezes. Freezing is a physical property. That's not answer. A solid is formed. Not always chemical reaction produce solids. It cannot a new kind of matter with different composition. That's a statement we are looking for. The substance you start with change to a different substance with different composition. Temperature of the substance increases. Even in a physical change, temperature could be, water could be heated up to boiling. Answer is C. Energy of a moving object. What is the equation? Kinetic energy is half mass times velocity squared. We shown that to you in the previous slide. Answer is B. Chemical energy is example of which of the following? What is chemical energy? It's a kinetic or potential. We talk about nuclear energy, chemical energy are potential energies. Chemical energy is associated with electron bonds. Nuclear energy is associated with bonding in the nucleus. Therefore, chemical energy is a potential energy. Nuclear energy is an example of which of the following? Nuclear energy is also potential energy associated with the nucleus. Which of the following is not a form of kinetic energy? Chemical energy is not kinetic energy. Electrical energy is form of kinetic energy. Light, mechanical. Only the chemical energy is not kinetic energy. A is the correct answer. Which of the following is a form of potential energy? Both nuclear and chemical we talked about. Both nuclear and chemical are potential energies. Answer is C. Which of the following is true as a student slide down a water slide? When you go down a water slide, what is true? Kinetic energy decrease, No, as you go down, increase. Potential energy decrease. Total energy increase. No. Total energy is conserved. Therefore, potential kinetic energy increase. Potential energy decrease. Therefore, correct answer is D. Oh, what is that? D. None of these. Total energy increase. That's not true. Potential energy. Oh, none of them are true because potential energy decreases. Kinetic energy increases. Therefore, answer is D.